All right, guys, we're going to have to get our thinking caps on this one. This is where we kind of get a lot more, we ramp up the difficulty. Basically, understanding is probably the most difficult part of this. The algebra is going to be also a little bit difficult as well. So it's going to be really important that you pay attention to this lesson. Pause if you need time on it. Also, make sure you do the homework. There's not a ton of problems. If you look at your homework, there's a lot of space for the homeworks. It doesn't mean you're going to fill all that up. I just know people write big, so I gave you lots of space. Not a ton of problems, but if you can do those problems, you understand what we are doing. So before we get to that, let's get to something we've already covered before that will lead into everything, and that is average rate of change. We did average rate of change a couple of units ago, so let's go ahead and recall what it meant to do an average rate of change. Now, an average rate of change is really just a slope. It's a slope between 2 points. So if I look at this graph here, basically a line that goes through 2 points is known as a secant line. So we have a secant line going through these 2 points. So our average rate of change is going to be the slope that connects both of those lines. To calculate slope, so if we come over here, our average rate of change right there, I just abbreviated ARC. Well, that is that slope of the secant line. Reminder that M stands for slope. Slope is just change in y over change in x. That's why I have that delta y over delta x. Now remember, all of these mean the exact same thing. Well, change in y is y2 minus y sub 1. Our change in x is our x sub 2 minus x sub 1. Well, we're going to go one step further and actually get these possible values. So if we come back here to the graph, I'm looking at the graph. We have two x values down here. I have an x sub 1, that was 1. I also have a second x value, which is x sub 2, which in this case is R5. That leads us to 2 points. These points right here, basically, take that x sub 1 and plug it into whatever equation you have. That will be our output. For our second point, we just have to take our second value, in this case it's 5, plug it into our function, and we have our second point. That will get us both our y values and both of our x values. So our example of this one is we're trying to find the interval from 1 to 5. Let's kind of note this real quick actually. Instead of saying y sub 2 minus y sub 1, what we typically do is we plug in our f of x sub 2. We'll use our function notation, because this function will actually tell you what to do with the values. Y doesn't tell you what to do. This tells you plug in your second x value, plug in your first x value, and then underneath it we'll have our second x value minus our first x value. In order to do this, we are already given our two x values. We have that 1 and that 5. 5 would be our 2, our 1 would be our 1. The only thing we really have to find to do average rate of change are these two values. What happens when we plug in the two specific values? So let's do our f of x of 1 first. In this case, our x of 1 is actually just 1. Well, whether you believe me or not, when we plug 1 into this equation, in for that x and in for that x, we're going to get out a value of 4.75. The calculator, that's not the important thing. The important thing is that 4.75. We can also plug this in our calculator and get it out. My next one I need to find is f of x sub 2. That would be f of 5. Once again, I'm going to help shortcut this. If I plug 5 into that equation, we should get out 2.75. If you struggle plugging it in, you should probably practice that now. In fact, we could just plug that in our calculator and get our table values. That'll be just as easy as plugging it in. All right, now they're asking for our average rate of change, ARC. Our average rate of change is the same thing as the slope of that secant line, which we said is going to be our y sub 2. Our y sub 2 is at 4.75 minus our first y value, which is 2.75, all over my 2x value subtracted, 5 minus 1. If we do that work, we end up with a slope of negative 1/2. That is our average rate of change. So average rate of change would be going down over 1 over 2, down 1 over 2, down 1 over 2, and we would get to that point. That is our average rate of change. It is based upon that secant line that we have there. Believe it or not, this right here is the heart of what we're doing today. We're going to be calculating slopes. we're going to build up to calculate the slope of a tangent line, but first we have to stick with secant lines for just a little bit. We also have to change our notation a little bit as well. So if we read through this, here's the problem though. We can calculate the rate of change from 1 to 4. In fact, we actually found the average change from 1 to 5. But this will be different than if I calculated the average rate of change from 1 to 3, or 1 to 2, or 1 to 1.01. All of those will come up with completely different slopes. And what if I want the average rate of change at 1? I actually want the average rate of change at 1. Which I put here is, which should sound kind of impossible right now because that's not a secant line, and all we can deal with are secant lines right now. But we'll put that pin in that for a second. Well, to simplify this, we will tweak the average rate of change formula to allow us to change values just a little more easily between all of these. So rather than having to plug in 1, 5, 1, 3, 1, 2, 1, 1.01, we can actually tweak this formula to speed up that. And in fact, this is going to get into something called the difference quotient. It's the exact same thing as average rate of change. We're just going to note things just a little bit different. So I have here average rate of change. Average rate of change, if I say average rate of change, typically we use this formula. We use that y sub 2 minus that y sub 1 all over x sub 2 minus x sub 1. Let's not change slides. Let's just erase that. Well, what I want to note is I don't want to use x sub 1 and x sub 2. In fact, I just want to use the letter x. I want to use the letter x throughout this entire thing. So I can no longer do x sub 2. I just want to use x. So I just want to talk about things in terms of this x value. Well, how we're going to do that is we're going to note to get from x to another value of x, we basically just need to add however long that is. Let's call it h. The distance from here to here would be h, and so this, instead of x sub 2, would be x plus h. Let's just see that back here real quick. I'm going to erase this real quick, and let's say instead of calling this 5, we would do something like, okay, if this is 1, instead of 5, we would get this distance out. We'll say it's 4, and so this here would be 1 plus 4, which is that 5 we already had. It's just a slightly different way to look at this if we don't actually know these numbers. So instead of doing x sub 1 and x sub 2, we're going to do x plus that distance gives us x plus h. That tweaks our outputs just a little bit. This one's going to look the same, more or less. Instead of x sub 1, we'll have x, plug it into our equation, and I'll get my y value. So I have x and f of x. For this one gets a little bit weird though, because we're no longer we're not plugging in x, we're actually plugging in x plus h. So that means our output needs to be f of x plus h. We'll note, once again, if I come back up here, everything would stay the same. That we'd have 1 and 1 plus 4. 1 plus 4 would go here, which is 5. 1 plus 4 would go here, which is still 5. So nothing really changed, just notationally we changed some things. This will slightly change our equation where I no longer have sub 2's. Instead, my second y value is going to be f of x plus h minus, and we just have f of x. Once again, the whole goal is to get rid of those 1's and 2's. That'll be all over my x value. My second x value is actually just x plus h, and we are subtracting x from this. Note, these things are exactly the same. Once again, I'm just changing how we're kind of looking at it. Instead of x sub 1 and x sub 2, we're having x and x plus h. One small thing is going to change here moving forward is I have a negative x that's going to cross out this x. That is actually a really important step. We'll see that in just a second. That's going to tell me that, hey, my slope of my secant, it could be written like this, but moving forward, it's going to be easier for us to write it like this, that f of x plus h minus our f of x all over h is going to give us the exact same thing the average rate of change will. These are the exact same formulas. They'll get the same values out. We just tweaked it a little bit to get rid of those x sub 1's and x sub 2's. So what does this look like in practice? Well, let's just do 3 examples down here. We're supposed to use the difference quotient. Our difference quotient is this guy right here. to find the average rate of change of f of x equals x squared minus 3 over these intervals. Now remember, when we have these brackets here, these intervals, these are both my x values. So this is my x sub 1 and this is my x sub 2. But we can't use x sub 1 and x sub 2. Instead, we're supposed to just use x and h's. Our h is just going to be the distance between these two numbers, so this distance here. So to get from 1 to 3, I add 2, so my h value is 2. So this says my slope of my secant line equals my f of, well, it says we're supposed to do our x plus our h value, as it says here, x plus our h value, that's our second x value, that should be 3. Do you notice it is 3? Then we'll have minus our first x value, which is 1. On the bottom, we just need h. Okay, let's keep pushing forward. F of 3, if I plug 3 in there, that'd be 3 squared minus 3, which is going to give me 6, minus f of 1. 1 squared is 1, minus 3 is negative 2, so we have 6 minus a negative 2, all over 2. Well, these minuses should turn into a big old plus. So we have 6 plus 2 divided by 2, which is 8 divided by 2, which is 4. That is our slope of our secant line, or our average rate of change. I do want to note that realistically nothing different happened from our average rate of change. This 2 plus 1 is still our 3. This 2 right here is still our 3 minus 1, which is our x sub 2 minus our x sub 1. It just speeds it up. Rather than having to do that subtraction every time, we just need to know our h value and we can move forward like that. Now if I have a 1 and 2, reminder, these are both my x values, my x sub 1 and x sub 2. Our h is 1 because we have 1 difference between there. H equals 1. Finding our measure of our secant line using our difference quotient. Our difference quotient says we aren't going to use x sub 1 and x sub 2. I keep stressing that. Instead, we're going to use our x plus our h, which happen to both be 1s. Not plus, but minus our f of our x value all over our h value. That is f of 2. Plugging 2 into our equation, 2 squared is 4. 4 minus 3 is 1. Minus, when I plug 1 into it, 1 squared is 1, minus 3 is a negative 2. 1 minus a negative 2, once again, we should picture that as being a big old plus sign. All over 1. Well, that's going to be 1 plus 2, which is 3, so our slope is 3. The final one I asked us to do is going from 1 to 1. Well, to go from 1 to 1, I have 0 units, which makes our h equal to 0. That means if I'm finding the slope using that difference quotient, we're going to say f of 1 plus our h plus our x value all over our h value. Well, notice this is really f of 1 plus f of 1 over 0, but more importantly, this does not exist. I can't divide by 0. Herein lies the problem. I need this. I need this equation. I just said right before that I would love to find the average rate of change at 1. But if I find the average rate of change, it doesn't exist there. That's a problem. But if you kind of think about the lessons that led up to this, you might already think about what we need to do. In fact, I'm going to draw a little picture here of what we just found. We found the average rate of change from 1 to 3. So that's that first graph. That is basically if I drew a straight line down those 2 points. That is my secant line. Remember, secant line goes through 2 points. That slope equaled 4. Then when we got a little bit closer, I said, what if we have x values of 2 and 1? Well, that slope equaled 3. Then we tried this one. Well, we said that was an error because that was a tangent. That's a tangent line. The tangent line we don't know the slope of. However, we can start looking at what it might be. If you look at what I kind of pictured here, so we had a slope of 4 if I did 1 to 3. 1 to 2 is a slope of 3. We could see that slope maybe going down. Maybe it's 2, maybe it's 1, maybe it's somewhere around those values, but we kind of see it counting down, 4, 3, and if I did something a little bit closer, so if you kind of picture, maybe a little bit closer, maybe I did 1.5, I can't really draw that line really well, but what if I did 1.5 instead of 2? What if I did 1.01? What if I just kept making that value smaller and smaller and smaller? And if you already know what I'm getting to, good job on you, because we're using everything we just did before and we're going to a tangent line now. So a tangent line is that line that touches the curve. I want to get that h value down to 0, even though we know at 0 it's an error. To approximate the slope, approximate the slope. That sounds like something we've been doing. Well, to approximate the slope of our tangent, we start with the point x and f of x. We use the nearby point x plus h and f of x plus h. And we said h cannot be 0. But I want to just approximate the slope. So instead of actually calculating it, we're going to find the limit. We're going to find the limit as h gets closer and closer and closer to 0. So this is what we're going to start solving for. Our limit as h approaches 0, because we know if it gets to 0, it's an error. But we know we can calculate limits. So I'm going to calculate the limit of f of x plus h minus f of x over h. So although h cannot be 0, we're going to get really, really, really close to 0 and approximate that slope. So we're going to get closer and closer and closer until we can approximate what that slope is. Let's see what that looks like. And before we get started, let's look at this example. We're supposed to find the slope of the tangent line. That means we can't plug in 2 points. We don't have an x sub 1, we don't have an x sub 2. We just have 1 point, and that point is -1, 2. Now, I'm going to point to that, and we're going to go back to a different problem. Note the parentheses around there. That means it's a point. That is vastly different than these problems. Notice I'm going to erase some of this stuff real quick so I can point it out. Notice the brackets here. The brackets mean that I have x sub 1 equals 1 and x sub 2 equals 2. When I go back here, we do not have both of those. We have an x equals -1 and a y equals 2. In fact, I don't really care about that. That's a point. They'll take care of itself. What I really care about is the fact that x equals -1. I don't have a second x value. That's what h is going to take care of for us. So this is, I give you an x value and you're still able to calculate the slope. However, we're not finding our average rate of change. Instead, we're finding the slope of that tangent line. To find that slope of that tangent line, we have to find our limit as our h gets really, really close to 0. So that point gets really, really, really close to that -1, 2, which is going to look like this. Well, our formula says take our x value and add our h to it. I don't know my h value this time. Don't tell me it's 3. That's not an h value to go from -1 to 2. We don't know the h value. The h value is taken care of by getting closer and closer to 0. So we have f of -1 plus h minus f of my x value all over h. Here's where the algebra is going to come in. We actually have to solve this. So be careful, don't write too big. We don't have a ton of room on these. But what I want to note is we need to take every one of these that says f of something and plug it in for that x. So the very first thing I need to do, I need to have, I'm going to try to help out just a little bit. I typically use brackets. So I'm just going to deal with this f of -1 plus h, and then I'm going to put all that in brackets so we can see it together. So I'm going to go ahead and I'm going to plug in the -1 plus h. Now that should be squared because it's x squared. It's that -1 plus h squared plus that 1. Now I'm done with that f of negative 1 plus h. Now I need to switch to that negative 1, and I need to plug that in for that x as well. So what I'm going to do is we're going to remind ourselves to move that negative sign down with it. I'm going to open a bracket for that new f of negative 1. We are going to have negative 1 squared plus 1. I'm going to close that off with a bracket. So the brackets are not needed. I just like them for organizational sake, that one of my functions gets put here, the other one gets put there. Just a lot of this just has to do with being able to keep yourself organized. Now we're going to notice that we have this negative 1 plus h squared. We need to actually do that distributing. So I'm actually going to go off to the side. I don't want to do it all within, so I'm going to make a little note to myself that I'm going to do some work off to the side just because I have a lot of stuff I got to get done. So I have that negative 1 plus h squared. Now remember, that equals negative 1 plus h times negative 1 plus h. For those of you that lost a point every single time you didn't do this, you're going to lose a lot more on this one because it's key that you know how to do this multiplication. All right, let's do it. So first thing I would do is I distribute that negative 1 to both items. Negative 1 times negative 1 actually turns into a positive 1. We have negative 1 times h, which is a negative 1h. Now we switch to our h. I have another negative 1h, and then I have an h times an h, which will give me a big old h that looks like a b. Let's make it an h squared. I'm going to simplify this just a little bit by moving the h squared over here. I have negative 2 h's, and I have a positive 1. So that's a little note. Get it done off to the side. You're going to have to do that a lot. And let's go ahead and finish it down here. I'll try to leave it in the same order kind of thing. My blue, so that negative 1 plus h squared we said equals that h squared minus 2h plus 1. And don't forget about that black plus 1 that's still there. I'm going to include that there. Okay, then we have minus. We could probably do this math here. Negative 1 squared. Notice that negative 1 is blue. Negative 1 squared. Once again, I'm looking right here. Negative 1 squared is 1. Plus 1 is 2. And everything's over h. All right, let's keep going. After this, it should just be simplifying. That's it. From here on out, it just should be simplifying. And the biggest thing you should always kind of realize, this is going to happen a ton in here. So I have h squared minus 2h plus 1 is plus 2 minus 2. This will always happen if done correct. I won't say always because there's rare occasions, but you always find that your constants will cross out. So if I have a plus 2, I better have had a negative 2. If that doesn't happen, you made a mistake. And that's over h. So our constant will always fade away. I also get a little sloppy. I should have that h goes to 0. I'm not expecting that. Just at the end, make sure you have that limit as h goes to 0. Now, if we look at there, we have h squared minus 2h. I can pull an h out of the numerator. I can change that to h times h minus 2 all over h. Our h's will cancel out, and we're just going to be left with our limit as h goes to 0 of h minus 2. Now here's the cool thing. This is one of those that we can use that direct substitution in. I couldn't in the beginning, so let's look way back at the beginning. I'll circle in red. If I would have plugged 0 in here, we would have had an error, and we'd be done. But here we can actually take that 0 and plug this in and actually get a number out. This will actually equal 0 minus 2. So our end answer, our slope of our tangent line is just negative 2. So it could be a lot of work, a lot of little handwork, a lot of taking your time and writing neatly, but the process isn't all that complicated. And you'll notice it's just this nice little pattern that's going to happen over and over and over again. That's why it's important that you do your homework. I will once again do one more problem. We have 2x squared plus x. This time we're just given x equals 2, but if you remember from this last one, I said the x is the only important part. So we're good. We got everything I need for this one. To find our slope of our tangent line, we just have to remember that we're looking for a limit. As the point gets really, really close to that x equals 2 of our, and we'll still do our f of our x value plus h plus, not plus, minus our f value of our 2 all over h. Our job is really just to fill in those two numbers. That's it, and they give it to us. They give us that value every single time. If I come back up here, I can't really circle it out, but I'll go, we just plugged in a -1 there, and we plugged in -1 in there. Our job is just to plug it into this first thing, and then it just is algebra. Let's look at the algebra of this one. We're going to have that equals the limit. I'm just going to put limit. We'll put the h of 0 later. So f of 2 plus h, that means I'm taking this 2 plus h and I'm plugging it in for every time an x appears. I will once again try to keep you organized by opening a bracket and saying I'm dealing with just that f of 2 plus h. That's going to give me 2. I'm inserting that 2 plus h. We have it squared plus that x there, which is 2 plus h. I am done with that then. I plugged everything in and I wrote the exact, I have 2x squared plus x, except I replaced the x with 2 plus h. Then we carry down that negative sign. Now I have to do f of 2. That means I put the 2 in for both those x's. So I'll have 2, put the 2 in place of that x. I have 2 times 2 squared, and we have plus another x, but instead of x, we're going to have a 2. And that's going to be all over h. Now, I will point out that we are going to 0. This is not a direct substitution. It's not going to work until we simplify it. This will not work until we simplify it. So we got to simplify what happens here. The first thing I'm going to notice is I do have a 2 plus h squared. So you may want to just go up, make a little note to yourself that you're going to do a little work up here off to the side that I have 2 plus h squared. Once again, 2 plus h squared is the same thing as 2 plus h times 2 plus h. As we do this, we're doing 2 times 2, which is 4. I will note that I have a 2 times h, but I also have an h times 2. That's a 2h plus a 2h, which would give me a 4h. And then finally I have h times h, which would give me an h squared. I am going to rewrite this as h squared plus 4h plus 4, but I'm going to do one more step here. Actually, let's just keep going. So we now have a bracket. Don't forget about that 2 up front. I'm replacing that 2 plus h squared with our, I'm just going to change it up a little bit, h squared plus 4h plus 4. Same thing, just reorganizing it. And then we have that plus 2 plus h minus, well, we're going to have, what is that? 2 times 2 squared is 4, times 2 is 8, plus 2 is 10. So this is our 10 all over h. Like I said, you got to write kind of small to make sure everything fits. Now what I need to do is I do need to distribute this 2 to everything. So let's keep going. I'm going to write down here. So now we have the limit. As I distribute that 2 to everything, we are going to now have, what, 2h squared plus 8h plus 8. And we still have that plus 2. And we still have that plus h just hanging out there. And don't forget about the fact that we have minus 10 all over h. Now to do a little bit of work here, we're going to notice this negative 10 and this 8 plus 2 are going to go ahead and those are going to cancel out. Your constant will always cancel out if you did it correctly. That will leave us with 2h squared. We have 8h plus that h, which would give us 9h. So once again, I was looking at that 8h and that h right there to give us 9h all over h. Now, if you remember from our last problem, I factored out an h, so I could divide it out. Another way we can do that is we can actually see that h goes into both of these. And so instead of 2h squared, we're going to have our limit as x goes to 0, not x, we're going h goes to 0, of instead of 2h squared, we have 2h. Instead of 9h, the h's will cancel out, and I'll have a plus 9. Now this is a direct substitution one, so this will equal 2 times 0 plus 9, which will just equal 9. So realistically, the hard thing is remember the formula. That shouldn't be hard. We just got to remember a formula. The hard part really comes in these two steps, that we need to algebraically get those two steps correct, because otherwise everything else just kind of cancels out and whittles down to just a number. If it doesn't, you did something wrong. All right, if you look at your homework, like I said, you're going to notice that you have, I think I put 2 on each page. You should have plenty of room to show your work and to work through it slowly, even if you write big. However, if you need more space, hey, not a problem. Just write on a separate sheet of paper. I think the very last page is actually blank if you need a little extra scratch work. But remember, math has to do with staying organized. You shouldn't be writing all over the place in giant letters. You should find a way to be concise in your writing and not have to write super big. But you have the space to do it. All right, guys, good luck. I'll see you hopefully during our next lesson. Do the homework, do the homework, do the homework, do the homework, ask questions. Our next 2 lessons are the hardest part on the test, otherwise the test should be a rather easy test. Do your homework. Good luck, guys.